Audibility is clear to all of you. Nice. Now, we were discussing about gaseous state. We are in the next session of the gaseous state. In the previous class, we have discussed about kinetic theory of gases. Then we have done kinetic energy of gas, and we have taken all possible cases. Now we are discussing another aspect known as Maxwell's distribution of molecular velocities. The heading is Maxwell's distribution of. Till this point, you don't have any objection in English. But when I say the word molecular velocities, you may have an objection, sir. I think this may not be a correct word because you should say the word molecular velocity. Because if suppose for example there is a body is in motion, you can say, sir, speed of the body is equal to x, speed of the body is equal to y, velocity of the body is equal to alpha. You cannot say velocities of the body, speeds of the body. No, it is not the word we use normally in our language of English. But here I am writing the word velocities. That is the first question which has to be created as a doubt by the student, sir, why you are writing the word molecular velocities. Yes, answer is, remember that whenever we are discussing a sample of gas at any given temperature, remember all the gas molecules are in motion, and the motion is said to be random motion, and we are having intermolecular force of attraction almost zero. Therefore, remember that there is a possibility of collision with walls of the container. In doing so, velocity will remain the same, direction of motion will change. However, when there is a possibility of intermolecular collision, we have discussed in the previous classes, whenever two molecules collide with each other, during that, since we have elastic collision, there is a conservation of momentum, there is a conservation of kinetic energy. Therefore, it is possible that there will be exchange of velocity. Yes. If you are having exchange of velocity, if you are trying to enjoy this example, go back to your childhood when you were playing with the marbles. There will be a marble kept at one particular place, and you are having one marble in your hand. Once you push it with a certain power, depending upon your caliber, the first marble will remain as at rest it was there, and the second marble with which you are hitting, second marble goes to that particular point, and the first marble will fly up from there, right? This is supposed to be exchange of velocity. Similarly, in case of gaseous state also, we have exchange of velocity. If you are saying that exchange of velocity takes place during a collision, then the question, sir, how many collisions are possible in 1 second? Remember that in 1 second, science says that a billion type of collisions, billion number of collisions are possible. Our mind may not accept it. Sir, ऐसा नहीं हो सकता. ठीक है. Are you able to accept that there are 100 collisions possible? Let us take this one. Our imagination go to that point. If you are saying that, sir, let us say only 100 collisions are possible in 1 second, what is the meaning of that? This means to say 100 times velocity of gas molecule is changing in 1 second. Can you calculate what is the velocity at a particular instant? No, not at all possible. You're asking, sir, what is the velocity of a gas? It's over, changed, velocity is changed. Before completing of your question, velocity will be changed number of times. Therefore, it is never possible to find out. It is never possible to find out absolute velocity of gas molecules. Okay, sir, nice. What is the conclusion of the whole story? Due to a large number of molecular collisions within a given amount of time, which are perfectly elastic in nature, gas molecules undergo a large number of times change in their velocity. Therefore, it is never possible to find out the absolute velocity. ठीक है? If not, what to do? The other answer is yes. If it is not possible to find out absolute velocity, let us try to calculate average velocity. Yes. If we are saying average velocity, then the question roll number 1 says, sir, which type of average you want? Roll number 2 says, sir, yes, sir. In 10th class, we have done median, mode, right? In that case, we have calculated statistical average. So if means to say, whenever you are saying that you are not able to find out the absolute velocity, or whenever you are saying that you are going to find out average velocity, there are different type of average velocity calculations, right? Roll number one has one calculation method, another roll number two, another calculation method, like this. As many methods of calculations of velocity, find average velocity, so many velocities are available. Therefore, we are using the word molecular velocity. It is never possible to find out the absolute velocity of gas molecule. Therefore, what is to be written here in this case? Due to a large number of molecular collisions which are elastic in nature per unit time absolute velocity of gas molecules cannot be determined. ठीक है, right? Therefore, velocity, velocities of gas implies average velocity. And when you say the word average, it is not one, it is so many are there. There are so many types of velocities available. Therefore, we say, sir, we are having different type of velocities available, different type of average methods are available. ठीक है, चलिए अब when you are saying there are different types of methods available, how to proceed further? For that purpose, we'll take the help of Maxwell's distribution of molecular velocities. He has performed graphical method experiment he has done, and he has backup of mathematical tools also. We don't have mathematical discussion. We are having only study of graph in both IIT mains, advanced, and of course NEET also. What he has done, he has taken a particular temperature, say for example T kelvins. At that particular temperature, he has drawn molecular velocities. Okay, there is one more doubt, sir. Some of you are standing and asking, sir, you have defined, you have explained the term molecular velocities, why you are saying velocities, but you have not explained the word why you are calling it distribution. What is the meaning of distribution? Listen carefully, listen carefully. Suppose, for example, you are having a Sunday examination, and once Sunday examination is over, Monday you got result. Say, for example, the result has been dispatched on the notice board. Now, when you are observing carefully the notice board, what you are observing? You are observing the result of your classroom students. Then remember that for all the students who are there in the class, the teacher is the same. The content of discussion was same, right? And then the paper is also same. But even then, you may find that a group of students, listen carefully, I am trying to correlate our example with chemistry. A group of students will have very low marks. A group of students are having very high marks. And a group of students is having marks which are neither too low nor too high. Suppose, for example, the paper is of 100 marks. Then it is observed, not your examination result, any examination result. It is a custom, it is a normal method that out of the whole available candidates who are appearing for the examination, always there will be a group of students who will be getting very less marks, right? And there will be always a very small group, rankers, first and second ranker, and up to 10th, we can say that up to rank number 1 to 10 in India, the number of students are very small. That means whenever we are saying that, sir, there is a group of students which are getting neither too low nor too high, that group will be very high in our classroom result. If you want to have, go to your group, you are having result available, Take a print of that one and see what is happening, and that you can understand here really what Maxwell distribution graph says, that if you plot fraction of molecules, number of students securing score, right? dN by dt. What is dN by dt? Fraction of molecules which we are studying, right? Remember, whenever I say the word fraction, it means to say I am assuming that total quantity is equal to 1, because fraction is something out of 1. If I'd have taken percentage here, okay, sir, total you are taking as 100. Now here I have taken marks of students. And in our classroom today, what we are discussing? Gas velocity. Therefore, as we are learning marks here, in this case, we are taking this identical to comparison velocity. Come on, right? Now, what I said, number one, there will be a small group, very less number of students are available in our classroom who are getting very less marks. I have seen some of the marks negative also, like that. If suppose you are having this one, then the graph will go something like this. This is called Maxwell's distribution of molecular velocities graph. Yes. Now, suppose for example, if we are talking about this graph, listen carefully. I have taken this graph at temperature T, something 298 kelvins. See this one? How much fraction? A small fraction. How much marks? How much velocity? Very small. A small fraction of molecules possess very low velocity, right? But there is a very small fraction of molecules. See that? Very small. But see, what about their marks? Sir, very high marks. If you take this area, these are the total number of molecules. Take care of the question, 4 marks question. Area, doctors, area of this is equal to total number of molecules having very high velocity in our classroom. When the result comes out of 100, 99, 98, 95, they will be very small number. But remember, in every class there will be majority, very large number of students are available. Very large number of molecules are available which are having velocity neither very low nor very high, right? This is the velocity possessed by majority of the molecules. This is called distribution of molecular velocities. There are so many groups available here. I have taken 3 groups. A group with very less velocity, a group with very high velocity, and a group with intermediate velocity. Okay, right. At any temperature, these 3 groups are always available. Now what he said, listen carefully. This velocity along x-axis we have velocity. This is velocity possessed by major fraction of molecules. I am changing my language. This is velocity possessed by majority of molecules. No, sir. This is the velocity probable for number of students. Large number of students are having possibility to get this one. Therefore, this is called most probable velocity. The name of this velocity is most probable velocity. That means it is the velocity possessed by major number of molecules. People say VMP. We will write like this in our notes. Most probable velocity. Okay. Slightly more than that. See here. What is more here? Velocity is more. Slightly more than that, we are having another velocity. This is also a type of average velocity, right? Now, this velocity is possessed by lesser number of molecules, and this velocity is known as average velocity. It is called as average velocity. That is what type of average? As you do a plus b plus c by 3, that type of mathematical average. It is called as average velocity, and this is given as v. Come on. And Slightly more than that, we are having one more type of average velocity, mean, median, mode, as you say. Like that we are having. It is not that one. Like that I am saying. Like that. Another way of calculating is there is further more velocity. More I am saying. Further more velocity. This velocity is possessed by less number of molecules. This is known as RMS velocity. You have done already root mean square velocity. This is known as RMS velocity. That means according to distribution of a molecular distribution of Maxwell, we can say that, sir, we are having three different type of velocities. All these three velocities are mean velocities. There are different ways to calculate these mean velocities, right? Now, once you are understanding the graph carefully, come on, let us try to enjoy a question here. The graph indicates can you please give me answer? At any given temperature, dash velocity is maximum. Which velocity is maximum? Come on, come on, come on. Anybody? Yes, yes, very good, excellent. Abdullah Sohail, how you are saying average velocity, maximum का मतलब x-axis पे maximum कौन सा है? Answer is remember, it is always RMS velocity. Muhammad Moiz is saying most probable velocity, right? Remember that you have to see velocity. Velocity is along x-axis. I am asking which velocity is maximum? X-axis, which is supposed to have higher value. Okay, RMS velocity, right? Next, this is 4 marks. This is 4 marks. Next, at any temperature, dash velocity possess maximum number of molecules. Maximum, why you should say number? Let us write down like this. Maximum fraction of molecules. Now, come on, what is the answer? Yes, here it is MP velocity because fraction of molecule must be y-axis. Yes, you are right. It is called as MP velocity. Nice. Right? So at any temperature, MP velocity will have large number of molecules, whereas value will be less. Value will be less. Whereas if you are talking about fixed temperature, RMS velocity will have more magnitude, but the molecules which are occupying RMS velocity will be less in number. Okay, come on. Next. If we are saying this one, then you may have a doubt, sir. Okay, I know the value, or I know the names RMS velocity, average velocity, and MP velocity. How do you proceed for that? Derivations are there which are not in our syllabus, even for advanced examination. Therefore, we don't disturb our time. Okay, it is suitable for graduate students. Come on. MP velocity, most probable velocity. This is given as under root 2RT by M. You have to memorize that one. Enough. That is enough. We should not discuss further. Next, average velocity. Average velocity. Here we should discuss something because it is required in the questions. Come on. What is average velocity? Very simple, sir. Average velocity means, say for example, A, B, C, right? Then we can say A plus B plus C by 2. Let us see how to enjoy the game. Let velocity of first molecule be V1. Second molecule V2. Please write down completely. I am lazy. You people should be crazy. Third molecule V3. Fifth molecule V5. Then what is average velocity? You people are genius. Sir, very simple. It is V1 plus V2 plus V3 plus V4 plus V5 whole upon 5. Simple case. No, sir, I want to make complication because you people are uh, students of competitive examination. Therefore, sir, I want to create a typical case. A boy is creating this case. Sir, you are saying example like that. See my example, how I am creating. Let N1 molecules velocity V1, N2 molecules velocity V2, and so on, N10 molecules velocity V10. Now find out average velocity. Very simple. How to proceed? Average velocity is equal to N1 V1 plus, very good, N2 V2 plus N10 V10 by sigma n. Are you able to understand? Yes. If you are calculating average velocity, sometimes not for IIT people, for NEET people, yes, this is example given to you. 4 molecules are having velocity 200, 10 molecules are having velocity 500, 6 molecules are having velocity 200. Find the average velocity. Go ahead like this. N1 V1 plus N2 V2. What is N1? Number of molecules. What is V? Corresponding velocity. Right? Okay. No, sir, I want to have formula. No problem. In case of formula, we proceed like this. For us, average velocity is equal to, for gaseous state, under root 8 RT by pi m. Yes, we have to remember this. 8 RT by pi m. Similarly, we are having one more velocity called RMS velocity. RMS velocity is somewhat important for us. We'll start that on the next screen. Take down this. Go ahead. Any doubt to ask? Any question? dN by dt. Wait a minute. Wait a minute. Someone is asking about what is there on the y-axis. Wait a minute. This is dN by dt. What is dN by dt? Fraction of molecules with some velocity. With certain velocity. Okay. If you are asking what is RMS, sorry, beta, I don't know what is RMS because yesterday in the previous class we have done it. Okay, please just turn the pages, go back and check it that one. And Abdullah Sohail is asking M. Okay, very good. This M is known as कैपिटल एम आया तो पूरी लाइफ में पूरा यही है बेटा. कैपिटल एम जहां पे आता है उसको बोलते हैं मॉलिक्यूलर मास, नॉट नंबर ऑफ मॉलिक्यूल्स. शुड आई से दिस वन आल्सो? आर इज गैस कांस्टेंट, टी इज एब्सोल्यूट टेम्परेचर. टॉपिक होने के बाद प्लीज नाम मत पूछा कीजिए व्हाट इज आरएमएस, व्हाट इज एवरेज, व्हाट इज मोस्ट प्रोबेबल. ये हो गया, मैं पढ़ाया इससे पहले, अभी भी बोला हूँ, जब ये पढ़ा रहा था जब भी बोला मैं. If you don't know names of that topic, how can you understand the topic बेटा? चलिए 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 लिख लीजिए, लिख लीजिए. From this part onwards, the whole gaseous state is important, because examiner is not much interested in Boyle's law, Charles' law, because he knows that you are studying all these laws right from ninth class. Therefore, this is new entry for you people. Therefore, they will try to create more number of questions this side. What happened, Mukhid? Did you got the answer? Did you check up the previous pages? You can find out the name, what is the meaning of RMS, if you check the previous papers, if you have notes written properly. Got it, very good. इसका मतलब डेली आप नहीं पढ़ते हैं, डेली पढ़ना है तो समझो हम ये फ्रैक्शन ऑफ मॉलिक्यूल्स में आते हैं. If you are studying regularly, this is that fraction of students who are having very high marks. If you are not studying daily, it means we are having this type of fraction of molecules that having, I don't say anything. Abrar, you know what is the method of asking questions in the yesterday's question paper doubt? एक ही चीज को 4 महीने से पूछ रहे हैं आप लोग. मैं बोल रहा आपको कि अगर डाउट है एग्जामिनेशन पेपर में तो क्या करना, राइट? बहुत से बच्चे लिखे, उसके बाद उसका रिस्पांस भी हो गया, वो सब आ गया, पूरा काम हो गया, रूटीन में आ गया. फिर आज जब न्यूली बॉर्न बेबी के वैसा, सर डाउट है क्या करना, कुछ नहीं करना, एंजॉय करना लाइफ को. सिखाने का एक वक्त सिखाते बेटा, उसको जिंदगी भर हाँ ये साहब ऐसे हैं इसलिए करना. Yes, I have removed myself from the group because of unnecessary idiot type of questions. ये क्या है वो क्या है. I have removed myself because I don't have that much time बेटा. My time is suitable and valuable for so many students available in whole country, so I have to spare time with them. आज ज्वाइन होता हूँ उसमें, आप अगर डाउट है तो पूछ लीजिए, ठीक है? If time permits, I'll join today. Allah. Any doubt? Any question to ask? Shall I proceed? Is it over? Okay, go ahead, write down. If it is over, please tell me. Sigma and Muhammad Muiz. Sigma n means only number of molecules, but only n1 plus n, not v. Otherwise, I would have written n1 v1. तो एक ही चीज लिखा ना, दो नहीं लिखा बेटा. Is it over? Nice. Now, once we are having idea, I'm simply revising the whole thing in a small amount of time. It is not possible to find out the velocity, absolute velocity of a gas molecule due to large number of molecular collisions in a given amount of time, and these collisions are elastic in nature. Point number one. Point number two, since we are unable to calculate the absolute velocity, we are trying to find out average velocity. But the word average means, sir, there are different ways to calculate average. Yes, by using different methods, we may get different average velocities. We are trying to take up three such velocities. One is called as MP, one is called average, one is called RMS velocity. MP, as the name itself indicates, most probable. It is the velocity possessed by majority of the molecules. Point number one. Point number two, average velocity as mathematical average as you do in normal calculations of our life. And RMS velocity is very special type of velocity, which is highest always at any given temperature, but having less number of molecules. How to find out RMS velocity? Very simple, sir. Why we are taking unnecessary tension? Let us take care of the name. If you try to understand the name, you can enjoy the game. What is that? RMS velocity. Nice. When you are writing the word RMS velocity, then let us try to analyze. Let we are having molecule 1 and the velocity v1, all those things. You people are genius. I will not write once again. Suppose, for example, we are having velocity v1, v2, v3, v4, something like this for 4 molecules. Then what is the meaning of RMS velocity? Okay, very good. For a set of 5 molecules, let us take 5 molecules with velocity v1, v2, v3, v4, v5. How to write down RMS velocity? Very simple, sir. First of all, v1 plus v2 plus v3 plus v4 plus v5 divided by 5. What you have done? Mean you have taken. No, 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 sir. Square. Don't make 5 square, by 5, and then take root. Yes, answer is over. This is known as root mean square velocity. As the name, let us go in that style only. Answer is over. No, 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 sir. We are having N1 molecules. Let us take another story. Story number 1, right? 4 marks number 2. Let N1 molecules velocity v1, N2 molecules velocity v2 and dash velocity v5. If it is so, how to proceed for RMS velocity? Very simple, sir. RMS velocity is equal to first root, okay, then mean, okay, then square. That's all. No, sir, we are having N1 molecules. Don't take square with N1. Are you able to understand? Don't take square with N1, right? If you are having a number of molecules variable, then just apply square with this one. What is that? N1 V1 square. Yes. N2 V2 square plus N3 V3 square plus N4. Don't make, sorry, N5. Don't make square with N. Are you able to understand? This is supposed to be N5 and velocity of 5th molecule and square of that one. All right. If you are having this, please don't write the square term along with the number. and then divide by 5. Don't make 5 square. This is known as root mean square velocity. Okay, sir, I want to have formula of that one. What is the expression with which we try to calculate RMS velocity? Very simple, RMS velocity. Okay, this is important. Therefore, I'll show you derivation of this one. How to proceed for that? Okay, come on. According to, this is important in our syllabus. According to, why it is important? Remember, among the three velocities, which are average velocities, listen carefully. Whenever we use the word average, indirectly we are accepting that we don't know correct value. If someone is saying that I am having average marks of this one, that fellow don't know what is the accuracy. Therefore, when we are discussing average velocity, RMS velocity is one velocity which is not accurate. But whenever we are doing calculations of gaseous state problems, in all problems we try to prefer RMS velocity only. Go back to previous class. Kinetic energy is equal to 3 by 2 nRT, half mv square. What is that v we said? RMS we have said. Come on. According to kinetic gas equation, what was that? PV is equal to 1 by 3 capital M. What is capital M? Not number of molecules, molecular mass, RMS velocity square. Okay. What I do? Multiply and divide. Why we should take? I'll jump. You people are genius. Directly I'll take, sir, RMS velocity. This M. What is this M? Molecular mass. What is the meaning of molecular mass? Molecular mass means mass of a mole. A mole. Okay. When you say the word a mole, why don't you write PV is equal to RT? Yes. Listen to that one. This is M indicating molecular mass. Then this is RT is equal to 1 by 3 mv RMS square. Okay, my job is to find out V RMS square is equal to 3 RT by M. No, sir, we people are very much genius. Okay, jump here in this case. What is RMS velocity? Under root 3 RT by M. Under root 3 RT by M. Wait a minute. Who is that idiot? Okay. That is your close friend, that idiot to whom you have given the password and all in the previous classes. You have done right. जो गलती करे थे ना आप लोग शुरू में, आप में से कोई गलती करे थे या पासवर्ड दे देके, वही है जो अब आपको तकलीफ दे। अब आप बोलने पे मजबूर हो गए, सर प्लीज उसको हटाइए बोल के। उस वक्त हम आपको बोले तो आपको गुस्सा आ रहा था। चलिए अकल देर से आई तो कोई बात नहीं। That is the same idiot who is disturbing to you now, and you are sincerely enjoying the lesson, and that idiot, चलो ठीक है, अल्लाह मालिक, गधों को समझाना होना काम है। Now this is known as RMS velocity under root 3 RT by M. थोड़ा सा पीछे जाइए. What we have said, average velocity 2 RT under root 2 RT by M. Rhythm देखो, 2 RT by M, right? In case of MP velocity 2 RT by M. Average velocity में क्या बोले? Under root 8 RT by pi M. अब क्या बोल रहे हैं? Under root 3 RT by M. Yes. Now, once you are having this one, remember, in all calculations we use this one. It is said to be most accurate. Doctors, which of the following average velocities are said to be most accurate in calculation? Answer is RMS velocity is very much accurate. Therefore, we use only this one. Come on. If you are having this, then the question comes, sir, what are the factors upon which RMS velocity depends? I should ask the same question for the average velocity, for NP velocity also. Let us take commonly to all of them. Acha. When we are discussing RT by M, remember there is a shortcut here to solve the problems. Doctors, listen carefully. If suppose you have the value of R, it is a constant value. Only variable is what? Temperature. He may change in the question. Molecular mass also he may change. 3R I can simplify. If you simplify that in CGS system, how to proceed? RMS velocity is equal to under root 3 CGS I am saying, right? 8.314, are you able to recall? Yes, into 10 power 7 ergs per degree per mole. Temperature is variable. I am not changing that. Molecular mass, he can ask anything there. Therefore, how to proceed? Very simple, sir. VRMS velocity is equal to 1.58 under root T by M. Remember this formula. IIT people, yes, remember this one. This is in centimeter per second. RMS velocity is given as 1.58. Okay, 1.6 भी चलेगा. Calculation कर लीजिए. Under root temperature, kelvins, and molecular mass must be in grams because we are discussing in terms of CGS system. ये एक short method है. Especially whenever you want to save time, mostly problems are given based upon temperature only. This is suitable for us. Chaliye, next. When we are discussing RMS velocity, we have said RMS velocity is equal to under root 3RT by M. ठीक है. अब we know that when we are saying PV is equal to nRT, then if suppose for example you are taking this 3RT by M, in place of RT, is it possible to write, if suppose problem is given to you where RT value is not given to you, can you suggest any other equation? Yes, sir. Why don't you do like this? Suppose for example, if pressure is given to you, volume is given to you, go by this equation. Are you able to understand? Depending upon the problem, I am solving different problems. Temperature alone is given, go ahead. Volume is given, pressure is given, go ahead like this, right? Or else, suppose this is not given. Tell me what is density? Mass by volume. Here what is available? Volume by mass. Therefore, some people say if examiner gives you question in terms of density and pressure, why don't you enjoy like this? Yes, it is also one of the suitable method to find out the RMS velocity. Depending upon the problem, you can go with respect to any one of these expressions. Okay, when you are saying, sir, I know these many expressions, then my question is, what are the factors upon which RMS velocity depends? You will say, very simple, sir. By seeing all these observations, one can say something like this. Come on, what to do? Number one, if you are discussing about temperature, you can say, sir, velocity, RMS velocity, not only RMS velocity, any other three velocities directly proportional. I am studying RMS, therefore I write directly proportional to square root of temperature. Which temperature? Absolute temperature. V1 by V2 under root T1 by T2. Velocity depends upon this one. No, sir. Velocity is also depend upon under root molecular mass. Are you able to recall something from this discussion? Yes, go back to Gram's law. Gram's law of diffusion is based upon this statement only because rate RMS velocity is inversely proportional to molecular mass. If RMS velocity is more, rate of diffusion will be also definitely more. Therefore, remember that the Gram's law of diffusion is taken from the conclusions from this discussion. Okay, next. Now, can you please tell me how do you relate RMS velocity with pressure? What is the effect of pressure on RMS velocity? Can you please help me, anybody? What is the effect of pressure on RMS velocity? चलिए, गलती होगी, no problem, sir. We are students, we are learning. You have a right to do mistake, but you have to involve in the class. Anybody? RMS velocity directly proportional to pressure. Yes. Right? All the students, 89 students are available in our classroom. If all of them are sincerely involving, most of them are not sincere, however, if all of them are sincerely involved, everyone will say same sentence. What you people are saying, sir, directly proportional to square root of pressure, not directly pressure, square root of pressure. Very good. But see here, the enjoyment. What is the enjoyment? There is a beauty here. What is the beauty? Sir, if suppose you increase the pressure, what happens? Volume decreases. Mass remains constant. Mass remains constant. Density is equal to mass by volume. Density is equal to mass by volume. Mass remains constant. If you increase pressure, volume decreases. If volume decreases, density proportionately increases. अब आइए यहाँ पे, sir, if I increase pressure 2 times, density also increases 2 times. If I decrease the pressure 10 times, density also decreases 10 times. What is the net effect? No effect. Therefore, remember, दिखता कुछ और है, होता कुछ और है. Therefore, be careful. This implies RMS velocity, very, very careful, is independent. Yes, sir, independent of pressure. दिखने में कुछ और दिख रहा है, लेकिन इसका meaning that is like this. That if suppose, for example, you are applying the pressure, there will be no effect, independent of pressure. That fellow asks you, doctors, pressure ratio of applied pressure is 2:5. Find the ratio of RML velocity. First answer, under root 2 is to under root 5. No, sir. Answer is 1:1 because it is independent of pressure, right? Remaining discussion we'll enjoy in the next class. Please carry on. And if you have doubt, ask. Go ahead. Regarding test key, regarding doubts, all the things on the group, not in the class, because the others' time will be wasted. All right. I am not available in your group. I have removed myself. I'll add up today, right? And whatever you are having, please do it in that way. Mohammed Moiz is asking one question, sir. What about density? Time is not available, beta. Tomorrow we'll discuss, but tomorrow you have to give me answer. What is the effect of density on RMS velocity? आज नहीं, कल. आज पूरा सोचिए. Tomorrow we'll say the last one more bit is available, but time is not there. Therefore, we'll proceed. What is the effect? Moiz is asking, sir. What about density? Yes, that we'll discuss in the next class. Any other doubt? Write down completely, write the notes properly. Once I say that it's over, some of the students are running out of the classroom, right? Perfect idiots, please write down. And when I'm explaining, don't write. When I'm explaining, don't write. Every teacher has different method. When I'm explaining, simply listen to me carefully. Then I'm giving you time, write down in that time. A human being cannot do two things at one time. पहले समझ जाओ अच्छा, फिर उसके बाद लिखो. लिखने के बाद 2 मिनट देर हो गए, कोई बात नहीं, उसके बाद जाइए. ठीक है, क्लास में से भागना गंदगी है. Is it over? Go ahead. Write down. I am available. Those who have completed, they can leave the class, no problem.